Second part, we are looking at research proposal development. When one is doing research, the first thing that we said is that you need to identify the problem. Okay, what am I trying to find out about? So that is problem identification. The next thing that happens is that now you need to make a statement of the problem, and then rationale. How are you going to go about it? And then specific and general objectives, hypothesis testing, and literature review. So these are the things that we look at when you're doing research. But now, when you are developing research, the research itself, there is a process when you want to develop a research proposal. There's a process. The process in research, number one, you have to formulate the research problem. When you find out, okay, this is my research problem, and the research problem should be clear enough. This is the research problem that I have to answer. Now you have to do you need to look at literature. What are some documents that people have written about this topic? That is literature review, and it should be extensive. You need to read a lot of different books. You read them so that you find out about what you're trying to find out more or trying to research about. And then you are going to develop the objectives, and then you prepare the research design, including sample design. Okay, we'll talk about research designs to be another discussion. And then when you do the research, you prepare the research designs. These are just methods that you'll be using for to find out the information. For example, sometimes you can follow the people in time, like you start with them today, and then you are following them up. You see if they are exposed to a certain environment or to a certain aspect, what is going to be the result at the end. And then sometimes you are going to be looking at people now who have got a disease, and then now you try to go back in time to find out what really were they exposed to that made them to have this condition. So those are some of the research designs. We have got retrospective, prospective. So the way I've just described, you either follow people in time or you go back in time. And then you are now going to collect the data. After you do your research, you analyze the data. You now make what we call inferences. That is now making a generalization. Maybe you did a research on 100 people and you found out, let's say, that 80% of them were affected. So now you can make a general conclusion to say, okay, this disease is prevalent in this place. That's an inference. And then I can prepare your report and present the results. So please take note the steps in research. The first step is doing what? Defining the research problem. The second step is reviewing literature. Okay. The third step is the method that you are going to use. This is where you are looking at now, the developing the objectives and then research design, and then you are going to collect your data, and then you are going to analyze that data and then make inferences or conclusions, and then you report your findings. And when we are doing all these, the first thing you need to understand, you need to know something about what we call variables. A variable is a thing that we are trying to understand that can be measured, okay, or data that is collected about something whose value can vary from subject to subject. So variables can be discrete or continuous. You have got continuous variables and then discrete variables. So you need to differentiate those two that you've mentioned, continuous variable. Let's say, for example, if we're talking about height, height is continuous. You can have someone that is 1 meter tall, another one is 2 meters, but you also have numbers between. Blood group is not one that is continuous, it is discontinuous, it is discrete. You can either be B, AB, or O. You can't be A and B at the same time. You can't be O and AB at the same time. All right. So we have got an independent variable, a dependent variable, confounding variable, predictor variable, criterion variable. An independent variable is can be manipulated and it's a presumed cause. Look at this, for example. You are watering a plant. You have got water and you have got a plant. Water is going to be changing the size of the plant. So water itself is not changing, so it is independent. Okay? So it is an independent variable. It is a presumed cause. It is the one that is causing a change in the plant. While the plant is going to be, the size of the plant is going to be a dependent variable because it's going to be changing. Okay? So dependent variable has got a presumed effect or the outcome. It's also known as the outcome variable. It is the response that is measured. Confounding variable may not control for but can have effect on the outcome. You are not really controlling something, but you have got an effect on that thing. So you are a confounding variable. Predictor variable is the one that precedes the other, and we have information about it and use it to predict. So it's a predictor. For example, you have got, okay, what can I even give here? You know something about one thing, and then you know that if this thing is there, this other thing is going to happen. So you are using one thing to be able to tell what can happen later on or to predict the outcome. Okay. And then criterion variable is the second other thing that is being predicted. For example, you have got two things. You know, okay, if I've got this, anytime that you see this thing here, just know that someone is going to have this. For example, when it comes to, you guys will learn in pathology, one high yield topic, cervical cancer. You know, if you see there's what we call cervical intraepithelial neoplasms 1 to 3. So if you see CIN3, cervical intraepithelial neoplasm 3, that tells you that someone is likely going to have a cancer. So that CIN3 is going to be a predictor variable. And then the cervical cancer, which is the second thing, is going to be a criterion variable. So there are different levels of measurements. When you are looking at variables, they can be categorical or numerical. Categorical variables, these are qualitative in nature. Numerical variables are quantitative. So examples of categorical, which are qualitative, you don't express them in terms of numbers really. You have got nominal and ordinal. So nominal, these are unordered categories which are mutually exclusive. For example, like mutually exclusive, just direct opposites: male and female, smoker, non-smoker, sick, not sick. Those are nominal, mutually exclusive. And then ordinal, please take note that nominal and ordered categories. Ordinal, these are ordered categories which are mutually exclusive. Okay. For example, you every time you're talking about ordinal, think of always some things that you can put in order. For example, medium, you start minimum, moderate, severe, things that you can arrange in that order. For male and female, there's no way you can arrange them that you start with this. There's no orderedness. There's nothing like male, male, female, and then female. No, you can't order them. They are unordered. For ordinal, they are ordered. You can arrange them. For example, starting from the least to the highest. And then numerical variables, which are quantitative, can either be discrete or continuous. Discrete, these are all numerical values, typically counts. For example, numbers of visits to a dentist, these are discrete. Okay, these are all values. You don't have a decimal. And then continuous can take any value. For example, height 1, 1.2, 1.3, 1.5, and just like that. Okay. So categorical, as we have said, the categorical ones, we have got nominal and ordinal there. Nominal, the numerical value just names the attribute uniquely. For example, you can say, let's give 1 to males and then to females we'll give a 0. So it will be unique for them. Ordinal, the numbers can be ranked in order. Moderate, so severe, mild, moderate, severe, just like that. And then you have got the numerical ones. So also I've got continuous is scaled level of measurement. Here we have got the interval and ratio. You need to differentiate these guys. So what is an interval? What is a ratio? An interval is a distance between numbers. Okay. A ratio as an absolute and meaningful fraction. Ratio is a fraction. Interval is you are starting from one point to another. Okay, distance between 2 points, that's an interval. Ratio is a fraction. And really, when you're talking about ratios, okay, I think it's one thing that we'll talk about a bit later. So after understanding a variable, you also need to understand an hypothesis. An hypothesis is a statement about a relationship between or one, two actually, or more variables. Just a relationship, a statement about relationship. You have got a null hypothesis and an alternative hypothesis. Okay. For example, you can see this big thing here. Someone can make a conclusion. I've narrowed it to two hypotheses. It grew or it shrank. How can you see a very big insect? It's either it grew or it is us who became smaller. That's the only reason that's why this thing will become big. The null hypothesis refers to a general statement or default position that there is no relationship between measured phenomenon. For example, in biology, you looked at the chi-squared test. If you find that the calculated value is smaller than the one that is found on the table, you conclude that there is no significant difference. In other words, my conclusion and what this person concluded is actually the same thing. But if there is a significant difference, you conclude that, okay, my conclusion and what this person concluded, there is a significant difference. Alternative hypothesis means rejecting of no hypothesis. No hypothesis means insignificant or no relationship between two variables. What you have found out, or between this one variable and this other variable, they don't relate at all. Alternative hypothesis is you now rejecting that there is no relationship or rejecting the null hypothesis. Alternative hypothesis is a statement of what a hypothesis is set up to establish, opposite of null hypothesis. Okay. So you only reach to the alternative hypothesis if the null hypothesis is rejected. So I hope the example that I've given is clear enough. You do an experiment. Let's say, for example, Mendel found out that, let's say, the genotypic or the phenotypic ratio is a 3 to 1. And then you do an experiment. Even if it is not fully 3 to 1, let's say if you cross different breeds, okay, you cross different breeds, you expect that, let's say, the tall ones should be 75%, the short ones should be, let's say, 25%. But when you do your crossing, you find that the tall ones are 79, and then the short ones is the other number that remains, like an 11, sorry, 21. So in that way, you're not just for you to conclude if there is no significant difference between the values that you have found and the Mendelian ratio, you are going to use the null hypothesis, you use the chi-square table. If there is no significant difference, so you have got the null hypothesis there. So we're going to say there is no significant difference between the values that are found and the values that have been already proven. So probably what caused a difference with what I found out with what is already proven is just little errors in my work. But if you find out that, okay, there is a very big difference. For example, the ratio is supposed to be 75 to 25, and then you find 50 to 50. There's a really a significant difference there. So you are going to disapprove the null hypothesis, and then you are going to use the alternate hypothesis. Now, research has got objectives. And the objectives of a research, number one, should be clear and achievable. Okay. And they should be written as statements using active verbs. For example, to describe or to determine. This is how we write objectives, like the aim of a research. To describe, to establish, to assess, to investigate. Now, we use the mnemonic SMART for you to talk about the objectives of research. SMART. What does those stand for? S is specific, M is measurable, A is achievable, R is relevant, and T should be time bound. Okay. So your research number one should be specific, meaning that your objective should be clear, should clearly state what you or the person that wants to do the research needs to achieve. That's the meaning of specific. Be clear, what do I want to achieve at the end of it all? And then number two should be measurable. Your objective should include a measure that shows how you will know that the objective has been met. Imagine you are doing a research, but then after you accomplish the research, you don't know if you are done with the research or not. So it should be clear enough so that you can tell that, okay, I've now met what I wanted to achieve. So it should be measurable. Number three, it should be achievable or attainable. Your objective or goal must be possible to achieve, and you must have the tools and resources available. Imagine you start a research, you don't have money enough, or maybe what you want to research about is so scarce you can't find it in your location or your area, and you don't have resources. That is not achievable, it's not attainable. So that is a bad research. And then it should be relevant or realistic. Relevant. What's the meaning of that? Your objective must be realistic in that it's in your realm of responsibility to achieve. You don't start researching about something that you can't do. It should be you should be able to do it. And then number one, the last one, it should be time bound. Your objective should state an endpoint. Imagine you start a research that just goes on forever. You don't know when you are going to finish. So it should be time bound. Okay. So the initial research process involves you identifying the research problem. The research problem is actually what will give you the research question. For example, you know a problem that is at hand, and then now you create a question out of that problem. And for you to be able to answer that question, by the time you answer the question, it means that you have achieved the research problem has been met. And then there is also hypothesis. There are ideas that people have already given. And then now you set your research objectives. Okay. So after there is a clear research question, the second thing is now you review literature. What, why, where? So you look at literature. Literature review is the documentation of published and unpublished work from secondary sources of data in the area of specific interest to the researcher. So you look at the data that has been published and that has not been published from secondary sources of data, for example, books, magazines, journals, those are secondary sources. So, what is the purpose of the review of literature? To find out already investigated problems and those that need further investigation, to formulate researchable hypotheses instead of you trying to start up something that you'll not be able to research. Remember the objectives of a good research question. And then to gain a background knowledge so that as you research, you are going to know what you're trying to find out, and to identify data sources. Where can I find the data? Because if you review literature, you know where the one that already did it found out the information. And also to learn how others structured their report. What are the sources of literature? You can get from books, journals, also databases, for example, biographic database, abstract database, full text database. You also have government and non-governmental records and reports. You also have the internet, online journals, you have got database, for example, Poppyline, Medline. You also have research thesis. Someone already wrote something, so you can also look at that, or dissertations. And then, so you've looked at the literature. The next thing is you do now your data collection and data management. Okay. So there are different sources of data. You have got primary data. Primary data is the one that you are going to generate yourself, and then secondary data is the one that is already generated, published, or it can be non-published. So primary data needs to be generated. It is first-hand information. You can use a questionnaire, okay, like you are trying to ask people for them to be answering you at that point. the purpose is going to be saved. Analysis as per purpose requires more time because you are trying to do it at that particular time. So you spend more time, more money. Secondary data is readily available, is second hand, and there's no need of a questionnaire. Okay. It's descriptive and it's less expensive. There are different types of data collection methods. You can use an interview, either on person personnel, you're talking to a person, or telephonic, you call someone. You can also observe to collect data. You just sit in an area, you look at what happens in that area, how people live, you're collecting data. It can also be experimental, do an experiment. Also, you can do interviews and observations, or observation and experiment, or interview, observation and experiment combinations. So there are different forms of questions that you can use when you're trying to find out data: closed-ended or open-ended. Closed-ended categories are given already coded. This is a closed-ended question. For example, you went to see your friend, didn't you? So you're already providing an option for someone. Okay, they can't give descriptions. And these closed-ended questions are easy to answer and easy to analyze, but not so depth. Okay, they'll not give you a depth, and the investigators are biased because as a person is answering, you're already providing answers that they are supposed to give. Open-ended questions, the possible responses are not given. For example, what happened? Okay, so here you use these questions for seeking opinions, attitude, perceptions, and they provide in-depth information. The experience of investigator and analyst is also required. But the thing is that you are not restricting the person to giving only what you want. So some considerations when formulating questionnaires: use simple and everyday language. You don't want to use something that is complex. No, you are trying to ask someone a question so that they give you information. And you are using medical terms. You are using ambiguous language. No, because they will not understand and they will give you wrong data. Don't use ambiguous questions. Do not ask leading questions. The questions that will be taking you to some other things. The order of questions also matters. Okay. And they should be pre-testing. At least look at your questions before. So as you are writing down your data, there is a way in which you are going to tabulate your contents. Okay. In case you want to you've collected data and you want to write tables, you need to write the number of tables and in a sequence, the title of the table, the body of the table. For example, the row, the first row shows the heading. I should have written down. So for example, the first row, hope we know the rows here. So rows from up to down, and then those are columns, and then from left to right, those are going to be rows. So the first row is going to show the heading of a column. The first column will show the heading of a row. It's also important for you, in case you've collected data like tables, you need to also show the source of the data. Okay. And then you should also be able to make inferences like a summary of the table. You have got different types of tables, but don't worry much about that. Different tables are going to be used to explain or to write down different forms of research questions that we've answered. For example, you have got a descriptive question and you have got a quantitative question. So some of the, let's say for example, a quantitative, how many people have been affected? So what kind of tables can you use to be able to write down answers to a quantitative question? So for example, you can use an histogram, a frequency polygon, cumulative frequency polygon, scatter diagram, whisker and whisker, coloration diagram. So these ones can be helpful in writing down quantitative data, those data that you express in numbers. And then for qualitative data, this is the one where you don't have numbers, for example, male and female. So here you can use, for example, bars, a simple bar, multiple component. You can also use a pie chart, okay? You can also use lines, pictograms, port maps. Just what are that? For example, you can see here, this is the diagrammatic representation. This is a bar chart here, simple bar diagram, multiple bar diagram, component bar diagram. This is a pie chart, a line diagram, histogram, scatter diagram. This is for quantitative data, radar diagram, box and Wixer. So you've collected your data. The next thing is you report your data because we need to use it, right? So you have to report the data. So there are steps of writing a research, okay, of report writing after you found out your data. Number one, you should have a title. Abstract. Abstract is more like a summary. If you look at, just go on Google and then type Google Scholar. When you open Google Scholar, just search any question. Actually, when you are trying to search, they've given an assignment, an academic assignment. You can use Google Scholar. Just go on Google, type Google Scholar, you open the website, or, and then it will take you. You can now research anything. It is recommended. It will give you books or anything that you've written about that topic. You can also get your your references from there. Okay. So you need to have a title, an abstract, an introduction, the aims and objectives, the methodology, the observations, discussion, conclusion, recommendations, and also limitations. When you are doing your research, what do you think limited you so that the next person to come and do it, at least should take note of that? And then acknowledgements, what helped you or who helped you in your research, and then bibliography. So it's important for you to know the components. Okay. Recommendations will be based on our findings. For example, what do you think probably people that make laws should do based on your finding? Okay, I found out that this is the case. This is how many people are affected by this disease. What should they do now? Policy implementation, or the relevant authorities, what should they do? What do you recommend? You need to also take note about managerial and financial aspects as you get to do research, okay, because money should be considered. Okay, if there is no enough money, you can't be able to do that research, and the thing is that you'll not be able to gather the information. So there are some differences between a proposal and a report that we have to know, but I'm going to talk about the difference between a proposal and report when we'll be talking about a proposal, because it's a discussion. So some important things that you want to take note as we get to the conclusion of this discussion. When you have done your research, you are going to now use the data that you've collected to make some conclusions. So there is what we call sensitivity, specificity, positive predictor value, negative predictor value, prevalence, incidence rate, ratio, and risk ratio. Okay, so starting with a ratio, what is a ratio? A ratio is a comparison of two whole numbers in the same unit. Please take note, if you are saying something is a ratio, they should be in the same unit. You can't say 20 centimeters to 4 kilometers. No, that's not a ratio. It should be in the same unit. For example, 3 over 2, 4, which is 4 to 9, or 4 over 9, which is the same thing, or 15 to 9. You can. This is how you can write ratios. As a fraction, you use dots or you use the word to. You don't write units. And then you reduce the ratio to the simplest form. And then you also have a rate. A rate is a comparison of a number to one in a different unit, and it's always written as a single number. Okay, as a single number always. For example, 300 over 5. If that number is not divisible, you still write decimals, but you can see these have got different units. 30.7 words per minute, 3 children per family. Always write the units, divide it to simplify. That's a rate. You also have what's the difference between a ratio and a proportion. A ratio, as we've said, is a comparison of two values. They have got the same unit. A proportion is an equation stating that two ratios are equal. For example, 12 over 18 is the same as 2 to 3. That's a proportion. So there is so remember the terms that we are saying we should define: sensitivity, specificity. So we've defined rate, ratio. We also need to know the difference between prevalence and incidence. Prevalence is the proportion of a population that has a specific disease at a time. Incidence is the rate at which new cases of a disease occur. Incidence rate is the number of new cases of a disease during a given period, or the rate at which diseases are occurring. That is incidence. But prevalence is the number of people suffering from a disease at over a specific time period. So we need to differentiate that. Look at this diagram here. So there is a tap and then there is a sink, and then water is going into the sink, and then at the same time water is also leaving, and then you have got some water that is evaporating. So the amount of water that is going into this sink, we call it incidence. And then you have got some water that is leaving, some water is evaporating. The amount of water that is remaining in this sink, we call it prevalence. Prevalence is how many people have got a disease at a given time, while incidence is the rate at which new cases of a disease occur over a specific period. For example, over a period of 1 year, how many people, what is the rate at which new diseases are coming in, right? I hope that is okay. Rate at which diseases are coming in. How fast are people getting this disease over this period of time? But prevalence is how many people have a disease at this time. Okay, so in the prevalence, you look at the incidence, how many people, the rate at which people are getting sick. You also look at those that have recovered. That would be in this case the evaporation, and then you also look at the dead. So be removing the dead, be removing the recovery. So from the incidence, and that will give you the prevalence. So those that die and those that recover are no longer cases for you to consider in prevalence. And then you have got sensitivity and specificity. What's the difference of the between the sensitivity is the ability to test of the ability of the test to correctly identify those with a disease. So people that have got a disease, we call them true positives. And then specificity is the ability to detect correctly those without the disease. Okay, we call those as true negatives. Specificity is way better when it comes to determining people that are affected than sensitivity. Okay, so sensitivity is the ability to rule out disease if the test is negative, while specificity is the ability to rule in disease if the test is positive. So, for example, you have got people that have got a disease and people that are normal. So people that have got a disease and then they test positive for that disease, we call them true positives. But people that are normal but they test positive for the disease, we call them false positives. People that have got the disease but they don't test positive, they test negative, we call them false negative. And then people that are normal and then they test negative, those are true positives. So sensitivity is you looking at the people that are true positives divided by, so you sensitivity, you look at people that have the disease and then they test positive, divided by the total number of people that have got the disease, whether they test positive or they test negative. While specificity is you looking at people that don't have the disease and they test negative, divided by the total number of people that don't have the disease, whether they test positive or negative. Okay, I hope that's okay. So we have got what we call the negative predictor value and the positive predictor value. The positive predictor value, what you are looking at is the number of true positive. Let's look at this question, this table here. So you have got people that have got the condition. You have got 20 people have got the condition and then they test positive. And then 10 people have got a condition, but when they test them, they come out negative. 180 people don't have the condition, but when you test them, they are positive. And then 1,820 people have got no condition, but when you test them, they are also negative. So true positives, false positives, false negatives, true negatives. So when you are determining sensitivity, sensitivity is going to be 20 divided by 20 plus 10. Okay, like you add the 20 and the 10, that will give you the people that have got the disease. And then now just get those which are true positives. They have got the disease and then they tested positive. So it will be 20 out of 30. That's a sensitivity, 67%. And then specificity will be those that test negative divided by the total number of people that are negative. So 1,820 divided by 1,820 plus 180, that will give you 91%. So that is specificity. But now, when you get the number of people that are true positives, they have got the disease and then they test positive. You divide by the total number of people that test positive, whether they've got the disease or they don't have the disease. We call that as a positive predictor value. So in this case, it's going to be 20 divided by 20 over plus 180, that will be 10. Negative predictor value is the number of people that don't have the disease divided by the total number of people. So number of people that don't have the disease and they test negative divided by the total number of people that test negative, whether they have got the disease or they don't have the disease. That's the negative predictor value. Okay, so that is 92.5% in this case. And then we have got what we call the odds ratio. The odds ratio is found by, look at this, is A divided by C over B divided by D. So the odds ratio is basically the number of people, the number of cases that are exposed divided by the number of cases that are unexposed, and then you divide now by the control. Or let's use this one. Okay, this one is not a the odds ratio. So what we should just know is in the odds ratio, you have got people that have got the cases. Sorry, people that have got the disease. We call them the cases. Okay. And then you have got control. Control is the ones that we are trying to use to compare with those ones which we are calling cases. So for our cases, we have got those that are exposed. For example, we have got people that are sick, right? Some of them are sick but they're exposed. Others are sick but they are not exposed. And then for the control, like the ones that you are now trying to just use to balance with the work that you are doing, you have got those that are exposed and those that are not exposed. So you get the cases that are exposed, you divide by those that are not exposed, and then you divide the answer that you find by those that are exposed, the control, divided by the unexposed, which are the controls. Relative risk is the outcome rate exposed divided by the outcome rate not exposed. So when you are calculating the relative risk, you first find out the outcome rate and then outcome rate of the exposed and then the outcome rate of the not exposed. So the outcome rate of the exposed, you get the number of people that have been exposed divided by the total number of people. Okay, so you have got those that have been exposed, they have got the disease, and those that have been exposed but they don't have the disease. So you get the number of people that have been exposed and then they've got a disease. You divide by the total number of people that have been exposed, whether they've got a disease or not. And then the outcome rate of the those that have not been exposed, you get the people that have not been exposed but they've got a disease. You divide by the total number of people that are not exposed, whether they've got a disease or they don't have the disease. And then now you divide these two numbers, the outcome rate exposed divided by the outcome rate not exposed. That will give you the relative risk. So what is the relative risk? It's the ratio of the probability of an event occurring in an exposed group versus a non-exposed group. What? How? So if these people have been exposed, these people have not been exposed, what is the ratio that it will occur in the exposed and in the non-exposed? And you know, a disease should happen more in those that are exposed than those that are not exposed. After you have done that, at the end of it, you should make inference. After you've done your research, you should make inference. What is an inference? You need to make a conclusion. Okay. So that is it with the first part of this topic. So some questions you should be expecting in your test. If the objective of a research was to be modified as to determine the frequency with which the disease state occurs or associated with frequency of patient complaint, what type of research study would this one be? Remember, to determine the frequency. Frequency is number, so that is quantitative. Research methodology is A, the way of systemically and scientifically solving a research problem. B, the methodical way used for conducting research process. C, the methodical techniques used for conducting research process. D, the behavioral and instrumental involved in research. So remember, we said it's systemically solving a research problem, and of course there's the scientific there, because there are some steps that we're also following. Measurements in a research involve different styles and scaling techniques. The measurement scale that involves assigning number symbols to events in order to label or give temporal identities. Remember, temporal identities, like you can't tell, you don't, these ones are not ordered. Okay. For example, I said for males, you can say, okay, let males be represented by 1, females will be represented by 0. We call those as nominal scale. The ordinal one, these ones, you can order them. For example, mild, moderate, severe. Measurements in research involve different styles and scaling technique. The measurement scale that involves ranking number symbols to events in order of their hierarchy to label is referred to as. Now, these ones we can arrange them in order of hierarchy. So those are ordinal scales. Which of the following example in the listed below would best represent data at the ratio level based on the scale of measurement and research? Interval scale. So again, which of the following examples in the listed below would best represent data at the ratio level? Okay. Remember, a ratio is where we're expressing things that have got the same unit, isn't it? So interval scale, which one? So you have got temperature, age, blood group, pain. And they've even told us here interval scale. So when you're talking about age, age can be represented as an interval. You have got a beginning and then you have got the end. Temperature, of course, you can have a beginning and the end. Blood group, really, you don't have a beginning and the end. Pain, you don't have a beginning, or you can't really tell the beginning of pain and the end. But so temperature and age can stand in that case. But again, we want to represent them as a ratio at a ratio level, so age becomes the one that remain. Remember, a ratio, something that can be written in as a fraction and then with the same unit. Okay, so for example, you can compare the ages of two people. This one is 2 years, the other one is 3 years. So in that case, you can write the ratio. Which of the following sections is a component of a research proposal? Result section, discussion section, recommendation section, literature review section. So Which of the following section is a component of a research proposal? You have got a component for literature review. We've not talked about the research proposal itself, we'll discuss it. But at least we talked about the steps. Which of the following is the first step in the research process? Literature review, problem identification, researcher designing, sampling procedure. So we know that it's problem identification. In selecting a research problem, a researcher has to be able to take particular considerations that is necessary in problem identification. Which of the following is among the considerations to make during the selection of a research problem? Researchers' competence, researchers' performance, researchers' availability, researchers' interactions. So, which of the following is among the considerations to make in selecting the in selection of research problem? You need to look at the competence. Are you able to do it? Like, are you able to do it? Do you have a skill? Okay, that's a competence. All of the following are basic characteristics of research objective, except remember, research objective, it is SMART. That's a mnemonic. Specific, measurable, achievable, relevant, time bound. Durability is not there. Three of the following are important considerations to make during the review of literature. Which one is the odd one but regarding the literature you are reviewing? Relevant, related, recent, reactive. Okay, when you are reviewing literature so that you can make a research, should be relevant to your research, should be related to your research, and it should be recent. You don't want to get something that was done in 1900s. So reactive is not part. Which of the following is a research paradigm that is least concerned about generalizing its findings? So qualitative, this is not quantitative. In qualitative research we barely make generalizations, but quantitative, where you are using numbers, you can generalize your findings. What do you call a condition or characteristic that can take on different values or categories in research? A constant, a variable, a cause and effect relationship, descriptive relationship. So a variable is a characteristic that can take up different values or categories. A variable that is presumed to cause a change in another variable is called categorical, dependent, independent, intervening. Remember, independent causes a change in another. How would you define a hypothesis that is stated negative in research? So a new hypothesis is a hypothesis that's stated negative. A variable that is presumed to cause a change in another variable is called independent. Choose the appropriate grouping of the variables to be described as continuous variable for research study. Continuous, remember, number of patients with side effects, bottles with fewer than 100 tablets, white blood cell count. B, race placebo group in a clinical study, number of bottles of syrup that are cloudy. C, tablet hardness, blood concentration of drug, creatinine in urine. And then D, any ordered variable. So I want to look at a continuous variable. If you look at A, number of patients, number is not continuous because you can count. You can't, the number of people, you can't say there are 1.5 people here. No, I don't mean 1.5 as in thousands, but 1.5 as a number. You can't have a decimal for continuous. And then race. Race is not continuous. You are either this or that. You are not between. So tablet hardness can be hard, soft, not so hard. Blood concentration can be 1.2, 1.5. Creatinine in urine can be 500, 200, 100, just like that. So this one will answer it when you do the study designs. Even this one. How would you define a hypothesis that is stated negatively? Okay, we've done that. And then this one, mention 5 examples of how you can represent data, research data. So research data, depending on the type of data, you have got qualitative data you can represent as a bar charts, pie charts, line charts, pictograms, spot maps. And then quantitative data, you can use tables, histograms, scattered plots. So just pick any 5. List 5 inferential tests you can use to analyze your dataset. Inferential tests is a test that we use to make a conclusion. Okay, you can use correlation analysis, regression analysis, hypothesis testing, analysis of variance, binomial theorem, confidence interval, t-test, chi-square test, man whitening u-test, all those. Describe the key characteristics of research objectives. So these are 5 SMART, so you should be able to describe them. And then you have got this one here. The results from one study were obtained as shown in the table. You have got people that have got CHD positive, and then those who are negative. So of the positive and the negative, you have got those that have been exposed, those which are smokers, and then those who are non-smokers. So calculate the incidence for smokers and non-smokers. Remember, how do we calculate incidence? Incidence for smokers, you look at the number of smokers with the disease and then the total number of smokers. So I've got 84, they've got the disease. The total number of smokers, you have got 84 plus 2,916. That will give you 0.028. And then the incidence of non-smokers, you look at number of non-smokers with the disease. Okay, and then you look at the total number of non-smokers. Remember, incidence, you are looking at people that have got the disease and then they've been exposed, or people that have got the disease but they've not been exposed. And then now, what is the relative risk? So relative risk is now you looking at the incidence of smokers over the incidence of non-smokers. So you divide the two numbers. In one sentence, interpret your results. So we have found that the relative risk is 1.61. So the meaning of this is that the relative risk of 1.61 in case that smokers have got 61% higher risk of developing the disease in comparison to non-smokers. So just get this number. If you get this number, so you say 1 over this number, multiply that by 100. If someone asks you how to interpret the relative risk results, write down what you would say to him. So relative risk tells you how much likely it is for one group, in this case we're talking about smokers, to develop a certain outcome compared to the other group which do not have exposure. Okay, so a relative risk of 1 means that both groups have got the same risk. Relative risk greater than 1 means that the first group, those that have been exposed, have got a higher risk of getting the disease. And then so in this case, relative risk of 1.61 means that smokers have got 61% risk of getting the disease. Or just get this number multiplied by 100, but remove that one in front so that will give you a 61%. So anything above, if it is you get a number multiplied by 100. If it is above 1, just remove that one in front. So it will give, instead of it giving you 161, it will give you 61%. If it was below 1, just multiply by 100. It should be a number that is smaller than half. Name 5 study designs used in qualitative research. Okay, we'll talk about study designs in the next class. So these were questions from last year's test 1 and some questions in the exam. So hope that will help you. Thank you so much.